We're solving problem 23 from the fall MC12A from 2021. A quadratic polynomial with real coefficients and leading coefficient 1 is called disrespectful if the equation P of x equals 0 is satisfied by exactly 3 real numbers. Among all the disrespectful quadratic polynomials, there is a unique such polynomial P tilde x for which the sum of the roots is maximized. What is P tilde of 1? Now the problem gives us that P of x is a quadratic polynomial. Therefore, we can write it as such. Since we know it's quadratic, it has two roots. Call them R and S. So therefore, if we have this P of x, we know that this has to satisfy P of x equals to 0. Okay, so when you plug that in, you get that this is going to be x minus r times x minus s minus r times x minus r times x minus s, and all of this is equal to 0. So now that we have that, well, it's clear that these two are the roots, r and s, but it says that it has to be satisfied by exactly 3 numbers. So this means that one of these have to have 1 and one has to have 2. Since we don't know the variables, we can choose whichever. If we choose this one, then we have this. So we can just simply expand that. And what is that expansion? When you do that, this is simply x squared minus r plus s times x plus rs minus r is equal to 0. Now, if this one has a double root, that the discriminant has to be equal to 0. So, therefore, we can use the quadratic here by plugging it into the square root part. Now, since we don't want any variables of x, this is why instead of the coefficient of b being x, you write it as r plus x, as we know that those roots are not variables and don't have to change indefinitely. And therefore, that being said, this simply plugs into r plus s squared minus 4 times rs minus r equals 0. So we have that. Now, expanding, we get that this is equal to r squared plus 2rs plus s squared minus 4rs plus 4r equals to 0. And we can further simplify this down with these terms. This can simply just become r squared minus 2rs plus s squared plus 4r is equal to 0. Now, we can see here that these two independent variables, r and s, right here, can be factored into a square. This factors into r minus s squared plus 4r equals 0. Now we have that. Since you want to maximize this value, let's call the values of r plus s, the sums of r and s, to be an integer m. So simply, when you plug this in, this then becomes 2r minus m squared plus 4r is 0. When you expand this, this is m squared minus 4rm plus 4r squared plus 4r is 0. Now, since we have it in the form of a quadratic, we can then use the quadratic formula to solve for m. M, in this case, is equal to 4r plus or minus the square root of 16r squared minus 4 times 4r squared plus 4r. and then divide all that by 2. Well, this can all just simplify if you just do some mental crossing out here. And then divide the 2 is 2r plus or minus the square root of negative 4r. Which this is being divided. Since we already divided by the 2, well, we can see here that there's another 2 here in which there's a 4. We can take out the 4 but keep the negative inside the square root to make that a 2. So therefore m equals, factor out the 2, r plus or minus square root of negative r. Why can we do this? Well, when we multiply 2 by the square root of negative r, you get 2 root negative r. When you put that 2 inside the square root, there's a 4. So we drag out the positive component of this negative square root. Now, since this is a negative square root, might get a bit confusing. Let's call a variable, say, g, and set it equal to the square root of negative r. Now you can plug this value of g into both of these r's, as we do not want 2 variables simultaneously. That would be very messy. So m, in this case, is equal to 2 times negative q squared plus or minus q, simply. Now that we have that, we again want to maximize m, the value of m. So when you choose this sum, you want to add it. So our ideal value of m is equal to 2 times negative q squared plus q. Okay. So simply solving for this, you can factor out another q. M is equal to negative 2q times q minus 1. Now, when you put this on a graph on the xy plane, you can see that the vertex has at 2 points, 0 and 1. So you want to find the average between those 2 points. So the AV average is 0 plus 1 over 2, which is 1/2. Since we know that r is equal to negative q squared, we know that r is equal to negative 1/4. Now, you can plug this value of r into the original equations to get the value of m here, where we had m in terms of r. So m is 1/2. Well, now m minus m, you know that m minus r is s, so s is 3/4. And we can simply plug all these values back in to all these x's, and then simply just do 1 minus their respective values, and then multiply that out to get our answer of 5/16 for the first solution of this problem.